This little device is a little LoRa radio, a very cute PCB that's a bit like a bird, and it's in my idea is to connect my little single board computers to a main computer somewhere. So this is a nice way to do it. These little radios. It's TTL, so it has to go through a special converter. This is one that I managed to get working. I'll talk more about that in a bit. But for now, that is the bit we're looking at, and I'll go through parts and the like. But yes, let me go and plug him in, and we'll see where we go. So if I just plug him in to my serial port on my laptop, bear with, and then we'll make the light a bit nicer. So what I have here is, this is me on my laptop, and this is downstairs. I'm upstairs at the moment, so there's a little bit of distance, and it's a brick house, so it's not particularly nice for little radios to talk to each other. And LoRa is very interesting. It's very low bandwidth. You're not going to be passing lots of data. And these little radios, they come with UARTs. So essentially everything is controlled through UART. So again, it's quite nice and familiar. So this particular one, for example, I've just plugged it in, and he comes up as, hopefully it hasn't changed. He's come up as a little UART here. So everything's done through this AT command. So I need to get the list of commands. Hold on. Let me just prove that. So I think if you just go AT and send it, it comes back with an OK. You manually send the R in the end. So bonk, AT, and there it is. I've put a timestamp on this one because I just wanted to make sure. So that timestamp is me. Do it again. You can see a timestamp goes up. So this is a slightly newer demo than the one I've got on my Radxa downstairs, because I'm just happy to get it working, really. So let's go and have a look at my Radxa downstairs. So I'm no machining into it. So you can see here it says no machine desktop currently being viewed. So if we go into here and we go look at Visa Interactive Control, we go refresh, you can see it's got two. For some reason it always goes to serial 33, I don't know why. You can see it's a USB. Do you see the little TTI there? So that's cool. That's exactly what we want. So if I load the LoRa demo, so there's 33. And if we run him, I haven't quite got the timings and the pauses right. I think rather than weights, I need to be looking for my carriage return line feeds, which is that /R//N for anyone who doesn't know that. But you can see here it kind of works. That's fine. And then you can just sort of send messages to each other. Okay, so if we go there. So if I go let me just double check the address for each one, which there is a command. There's a nice little PDF here, which is the Reyax PDF. It tells you all the details. It's quite a nice little document, actually. And these are all the commands. So I'm going to put in a command abstraction sort of layer here, where I'm just going to put in all this stuff so that you can set them up in LabVIEW. So there's a whole driver set. But if we go AT plus address and then question mark, AT plus address question mark, it should come back with the address that it is set to. So AT plus address sorry, it's keyboard. AT plus address question mark, go here, go right. So he's address 1. So if we go AT plus address question mark, he's 2. You can see here I've got this a little bit further along. It's a much more responsive and it's a bit cleverer, and I flush buffers and things. But I was just keen to get it kind of yakking just so I could test stuff. Okay, so he's address 2. He's address 1. If I want to send data to 2, so I want to send data to him, I have to go AT plus send, then equals, and then it's where I want to send it. So he's 2, so I want to send it to 2. Then the number of bytes, so number of bytes, I don't know, let's go there, and let's go there, and let's go 87654. Alright, so I'm going to send 6 bytes. Alright, bonk. Okay, I've preempted this because I was playing with Frupa. Hold on. Bloop, you might have just seen it pop up. But I've got myself a little program in here that is actually just sending a number. So let me just turn him off. Okay, so we'll run him again. So now you won't see the response updating. So I go AT send 876543, bonk, and there he is, 876543. And you get another couple of numbers, which is kind of interesting. So you get this plus receive response. These numbers here are to do with, and there's a very good website, which I'm going to link to some of these websites, but it's linked to the signal to noise ratio and signal strength. So if I just bring it up, it's actually worth looking at their website because it's quite cool. Because the thing about LoRa is that it can send and receive data even in the noise. It's just magic. So you get this receive signal strength indicator. So you can actually read and change the LoRa parameters on the fly, I think. And if it's getting a bit weak, you can tune it. So there's ways of tuning it, which will give you a much better signal but a slower signal, so you can do really clever stuff. And I'm just beginning to explore this, but it's all very interesting. And then you have your signal to noise ratio. So your signal to noise ratio is the blue is the noise, there's your signal. That's bad. It's very hard to get a signal out of that. But they've been a bit clever, and they send the data in a particular format, and you can dig it out from surprisingly deep depths of noise. So yeah, kudos to whoever designed it, and kudos to whoever designed this as well. It's really nice. It's all very dinky, very straightforward, and I like it. So the idea behind this really is, I see with these little single board computers a slightly different way of writing or designing software. in that you've got lots of cheap platforms that work individually, but these cheap platforms you can link them together and they talk to each other. So you can spread out the CPU usage, you can reduce the wiring and things like that. And this is where I think LoRa comes in. I think for a very, very small amount of money, it's $17, I reckon. I'll bring up their website so you can. Oh no, shall I bring up the website? Hold on. Let's see if I can bring it up. Yeah, there it is. This is it just on Amazon. He says, "Come on." This is it just on Amazon. So I paid £16 per node. You can see I've bought it and been sat on it over Christmas. And yeah, they're really, really cool. Really cool. So, what do we know about LoRa? LoRa is based on a set of frequencies that are unregulated or not very highly regulated. Each country has different ones. So in Europe, ours is 868 megahertz, and I think America is 915, but I could be wrong. And then I've bought these little converters. So these are Hale Edge ones. I paid £4 each for them. You always get them in twos, and they're a CP21002. So in Windows, you have to install the Windows driver, and then it will come up as a VPC or as a virtual COM port. Unfortunately, I ran into issues trying to get that to work on, or get the other one to work on my Linux box. So I've tried various versions of Linux, and they just don't like those devices. They recognise them as USB devices, but that's it. So the default then is that they go into this HID, and you have to do all sorts of stuff to get them going in LabVIEW, which is just not interesting to me at all. So I bought some FTDI ones, which work quite nicely, and it's the same thing. It's just FTDI. So the one I got was, let me just find the part number. Oh, well, I'll link to the part numbers, but they're a standard part, and it's an FT232, I think, chip. And that they just plugged in and worked. So I could have just bought two of those instead, and they're actually cheaper as well. It's all learning, so I don't mind losing the odd pound here and there just to learn these things. But my idea is that I'll list a kit of parts that work, and we'll start building up a set of working items. And I just think this is a very nice way to deal with stuff, and I think actually for factory automation it might be quite useful as well. And you can sort of send a command to start a state machine going and things like that. So you could be, having a centralized control, or just, the standard thing is you could use these just for status. So they're sitting there going, every minute they'll send back a bit of data. So all of that. The range is quite high, but not in buildings. But it's still quite, I'd say it's quite high even in buildings. I haven't got to the bottom of what these numbers actually mean, but that is minus 46 dBm. And the signal strength is 12. As long as the signal strength is above 0, you're in a good position. So it's a wee. I think I read that as it's a weedy little signal, but it's more than enough because there's not a lot of noise either. And it works fine. It's probably not completely lossless, but you might and you don't really want to build a lot of bloat on top of the packets you send. It's really the lighter you can be, the better, the more data you can pass. But yeah, that's LoRa, Radxa, Windows. I'll just have a quick look at the block diagram. So I've preset it all up, so you won't see any setup stuff here. But essentially the setup stuff is the AT commands and its setup stuff. So what I'm doing is opening it up. I'm manually doing all the termination characters just because I wanted full control over everything. You could probably put in the termination characters as being character turn line feed, but I prefer to manually. I've tried to flush the buffers and things like that. Waiting a bit, chucking the data out. This is me putting a timestamp on the data just so that I've got I know it's been updated and I don't have to clear the screen. Yeah, and then I've got rid of that, so he just reads all the time. So he's just sat there reading, and if he hasn't got anything to do, he will just go around again. Yeah, and that's it really. So my intention is to write a little component that deals with all the messages that we see here. So that's fully described in LabVIEW then. So this would just be drop down boxes that describe these and format them for you, so all you have to do is put numbers in, and then you won't have to refer to the manuals, or I won't have to refer to the manuals next time I use it, and that'll be the project done. Right, I think that's long enough. I might do a very brief video on all of that once I've fixed it and made it all beautiful, so you'll just see the code in nice order. And then that will be that. And then next is I2C.